Hello, I'm Chunyu from the Chinese University of Hong Kong. Today I'm going to talk about how reliable are phonetic data collected remotely. This study was led by Peggy and was completed by Peggy, Yixuan, and me. The far from over pandemic has posed great challenge to all aspects of our life. As to phonetic research, the strict travel restrictions have made on-site recording of less accessible languages more difficult, if not impossible. The photo on the right was taken during my field trip to northwest China in 2019, before the pandemic. I think now it cannot be so easily done, since speaking into a common microphone may be risky or dangerous to some. But technologies have advanced recently with various online experimental platforms for psychological studies, for example, Gorilla, Qualtrics, etc., and Zoom. Zoom enables us to meet online and it opens up new possibilities. The advent of the smartphone is also great, with omnipresent recorders. Then, our question is, can these technologies be used in remote recording, and how comparable are these recordings to those made in ideal conditions? Remote recordings can be influenced by an array of factors. As professional devices are not available to speakers, the choices are laptops or smartphones. Along with it, different smartphones may record using different softwares. When recording using laptops, we have the options of recording using Zoom Cloud or local recordings. Another factor is audio format. Different smartphones and softwares have their own default recording formats, for example, WAV, MP3, M4A, AAC, etc. Some previous studies have looked into these factors. The table in this page shows the general information of these previous studies. To compare the performance of different devices, professional devices were always used as the reference. Smartphones and laptops were also used. The recording materials were in general simple, such as pure tones or sustained vowels. Various measurements like F0, Formants, center of gravity, and so on were also made on these recordings. As indicated by the bold texts, F0 was quite comparable among different devices, and so was F1 among formats. In this light, our study has the following considerations. We recorded in two environments, the phonetic lab and the quiet conference room. We also used professional devices, smartphones, as well as laptops. Recordings were also made using Zoom Cloud recording and local recordings, and as a result, recordings end up in different formats. One of the most remarkable differences of our study from previous studies is that we used controlled speech materials in order to interpret the difference in a linguistically meaningful manner. We hope to see what is a viable protocol for collecting speech data remotely online. The materials we used were simple CV syllables of Mandarin Chinese, where the consonant can be either stops, fricatives, affricates, or sonorants, and the vowel were either I, U, or A. These syllables covered all four tones of Mandarin Chinese. Accidental gaps were filled in with pinyin, and systematic gaps was ignored. As for recording, our aim was to simulate the realistic situation of remote recording by amateur speakers. Therefore, we only controlled the basic settings, and more advanced settings were left uncontrolled. As mentioned, we recorded in a phonetic lab and in a quiet conference room. The second author of the paper was our speaker, who is a 25-year-old girl. We recorded 2 repetitions for each condition. To compare different devices, we made simultaneous recordings using different devices. The recording by Zoom and iPhone were in M4A format, and that using OnePlus were in AAC format. These were converted to WAV using iTunes and up in macOS. The different devices had different sampling frequencies, which was obtained in Pratt apt conversion. As our recording was simultaneous for different devices, the same segmentation under the same condition were used for different devices, except for Zoom cloud recording, which was corrected. The reason will be explained below. The following measurements were made on the recordings. Duration was measured only for H2N and Zoom cloud, as only Zoom cloud was segmented separately. F0, the first two formants, and the first 4 spectral moments were also measured. Voice quality measurements, including the formant corrected H1 minus H2, jitter, and shimmer, were also measured. The measurements by H2N were used as the reference for different devices. Our presentation will focus on the difference between different devices, since the difference between different recording environments is quite small. First, let's take a look at the Zoom cloud recording, which is the only one different from other devices in duration. The waveform on the right is an example. The top is the recording by H2N, and the bottom by Zoom cloud, and the word is me. It is quite clear that Zoom cloud is longer in duration and seems to be interrupted in the middle, whereas here. This is perhaps due to the internet connection. F0, as previous studies, are quite consistent among different devices, especially for T1. Where is this tone? The high-level tone, and most different for tone 3, this one. The low-dipping tone with creaky voice in the middle. There is also some difference in the offset of T4, this one. The high-falling tone. As for formants, the different devices are also quite consistent in F1, as shown by the figure, which shows the average formant values in the middle of the vowel. F2 is more influenced, especially for the high front vowel E. Almost all devices have lower F2 than H2N, and this is H2N, and this is all other different devices. This leads to the result that the vowel triangle of all other devices will dragged backward, and it can result in erroneous interpretation of the vowel system. The devices can be divided into 2 groups as for spectral moments. The figure on the right shows the box plot of center of gravity for fricatives of different places of articulation by different devices. H2N, iPhone 6, and iPhone 8 grouped together, which have higher center of gravity, especially for the fricatives f, s, and xi, while other devices grouped together, which have lower center of gravity. It seems damping frequency has an effect. H2N and the iPhones have sampling frequencies higher than 40,000 Hz, while Samsung, Zoom Local, and Cloud all have sampling frequencies lower than 40,000 Hz. But OnePlus also has the sampling frequency higher than 40,000 Hz, which groups with the latter. The audio format perhaps also has an effect. The voice quality measurements, jitter and shimmer, are also comparable for different devices, but the results are different for H1 minus H2. The figure shows the data of H1 minus H2 by different tones by different devices. The red reference line is 0 dB. For most devices, T3 has a negative value, T3 is this one, of H1 minus H2, reflecting the creaky voice, and is lower than the other 3 tones. But for iPhone 6 and iPhone 8, these two, the 4 tones have comparable values of H1 minus H2. Therefore, the distinction in voice quality of different tones is not captured by the iPhones. Using different devices and different measurements, we found that Zoom cloud recording is bad in duration and also in recording quality. F0 is quite reliable for different devices, as also reported by the previous studies. F2 is more influenced by F1, and H1-2 is H2 is critically influenced by the device. Sampling frequency and perhaps audio formats have also an effect on spectral moments. The performance of different devices are also related to different measurements. The smartphone OnePlus has relatively poor performance in Formants spectral moments, which is recorded using the AAC format. iPhones are relatively bad in capturing the distinction in voice quality, especially for H1-H2, and the Zoom cloud recording is influenced by the internet connection. Based on these results, we make the following recommendations for remote recording. First, smartphones and laptops can be used in the study of tone and intonation. Smartphones and laptops should be used with caution in the study of segments, and some of the devices may come up with unreliable results in voice quality studies. As the Zoom cloud recording is not reliable, another alternative is to use local recording of the laptop with online assistance through Zoom. Of course, this study by no means exhausts all the questions of remote recording. The influence of the audio formats and sampling frequency, as revealed by the present study, need further study. Thank you for listening, and if you have any other questions, please contact us using the following email address. Thank you.